So in the last episode, we talked about the Curiosity rover and a basic overview of its mission. In this episode, we're going to change gears and discuss the orbiters around Mars and talk about what their value is and what they've been able to do over the last 18-year time frame. So let's talk about that. So before I get started, we're just going to discuss operating spacecraft. That means spacecraft that are orbiting Mars and are still operating to this current day. So to begin, let's talk about the 2001 Mars Odyssey. In October of 2001, the spacecraft entered orbit around Mars, hence the name 2001 Mars Odyssey, like 2001 Space Odyssey, the movie. Now, the purpose of this mission was to understand the geology, the atmosphere, and the ice patterns that were occurring on the surface of Mars. It did this by taking spectrometry data as well as thermal imaging data to just understand what the temperature range was, to see whether or not water existed in the atmosphere, and to understand what the landscape of it looked like for the future rover landings that would happen a few years later. The next mission to talk about is Mars Express. This is a European Space Agency mission and was the first of theirs to be a planetary mission outside of Earth. It started orbiting Mars in December 25th or Christmas Day in 2003, and it had a lander named Beagle 2, but it wasn't able to deploy after it had landed on the surface, so that was considered dead. Now, the orbiter itself was actually extremely successful and is still operating today and predicted to go until 2020. And what it's been able to determine is different mineralogy of the surface of Mars, a better understanding of the landscape, the topographic regions, and lastly, understanding of how the interplanetary medium, the solar winds, and the magnetic field of the sun affects the atmosphere of Mars. And this is some of the first stages of understanding how Mars might have lost its atmosphere. So the next orbiter is the Mars Reconnaissance Orbiter, also known as MRO, and this was a NASA mission that started orbiting on March 10th of 2006. Now, the purpose of this one was to understand more of the landscape, the topographic regions, and also take daily measurements of the weather patterns and try and get an understanding of what their patterns are like and how that might be similar to ours here on Earth. The MRO is also very important because it acted as a telecommunications relay between Mars rovers or anything on Mars back to Earth. So if anything needed a boost in its communications power, it would go through the MRO and then come back to here on Earth. Now the next Mars orbiter wasn't for another 8 years, in September 20th of 2014. Now this was not by NASA or the European Space Agency, but was actually done by the ISRO, or the Indian Space Research Organization. And this was the very first Asian nation, or India was the very first Asian nation to actually put a man-made object in orbit around Mars, was also the first nation to ever do it on their first attempt, which is actually very phenomenal. Now, what's even more interesting about this was that they were able to do it at a price that's about 1/9 or 1/10 of what NASA would typically do for a similar mission. And even though they didn't have as much scientific data and they are only really measuring the carbon dioxide and carbon monoxide on it, it still showed their technical achievements and that they were able to do something cheaper than what NASA or the European Space Agency could do. Now, speaking of NASA, just a few days, 2 days actually, September 22nd of 2014, NASA had sent the Maven project, and Maven stands for the Mars Atmosphere and Volatile Evolution Mission. And this mission is primarily focused on trying to understand how Mars lost its atmosphere. Better understanding of what Mars Express had done on how does the interplanetary medium affect Mars, how does it know how much the atmosphere is lost every year, how does that happen depending on the Martian magnetosphere that it has itself, and also just basically understanding how the atmosphere works and predicting when it might have been larger in its history. So the last and most recent orbiter is the ExoMars Trace Gas Orbiter, which is developed by the European Space Agency and the ROSCOSMOS, which is the Russian space agency. It entered orbit in October 19th of 2016, so just a little under 2 years ago, and it also had a lander called Schiaparelli, but it also did not work successfully. It tried to land in October 2016, and it crashed into the surface of Mars. Now, that did not stop them from still using data. The mission overall was trying to understand how methane fluctuates in the atmosphere and whether or not that could actually be affected by microbial life still existing on Mars. Now, more importantly, this one, similar to some of the past ones that NASA had, was going to act as a telecommunications relay for the Mars Express rover in 2020. that European Space Agency and Roscosmos is also working on. So even though their lander didn't work, the European Space Agency and Roscosmos was still very successful with this and is still operating it to this day. So now that we discussed all 6 of the orbiters that are currently around Mars, we're going to go a little bit in more depth in the next episode about the 2001 Mars Odyssey, and we're going to go in depth about the Mars Reconnaissance Orbiter, what discoveries they made, what they're doing now, and what their plan is for the future. Thank you for watching, and I hope to see you in the next one.